Hello, welcome to this video. In this video, we'll be looking at the chain rule. So first off, we'll try to differentiate the functions that we've been given here. So we let this function to be equal to y. How do you think we would do this? From what we know so far, we have x to the power n. When you differentiate this with respect to x, we get n times x to the power n minus 1. So let's try that here, but x plus 3 instead. This will be 2 times x plus 3 to the power 1, which is 2 times x plus 3, which is 2x plus 6 if you expand it. Okay, and how about for this function right here? If we let y be equal to this, x squared plus 3x to the power 7, we suspect that dy dx would be 7 times x squared plus 3x to the power 6. But are we correct though? We can check. So we could expand that. We know that x plus 3 all squared is x squared plus 6x plus 9. And if we differentiate this, when you differentiate x squared, you get 2x, and you differentiate 6x, you get 6. Differentiate 9, you get 0. So this is indeed correct. Okay, how about this side? Now, it might be hard for us to expand up to the power of 7, but what do we know? We know that the highest power of x in this expansion, the highest power of x in that expansion, is going to be x to the power 14. And when you differentiate x to the power 14, you get 14x to the power 13. However, in this expansion, you can see that the highest power of x is going to be 12 because you'll have that 2 raised to the power 6. So you can see the highest power of x is going to be 12. So that means that this is wrong. So let's see how we can correct this. So the chain rule is the rule that we shall use to differentiate a scenario where we have composite functions. If you have y as a function of t, and when t is a function of a different function of x, then we want to get dy dx. Now we know that the ratio of the small changes in y and x can be given by this equation right here. Delta y out of delta t times delta t out of delta x. This is obviously true because it's true algebraically, yeah? But what do we know? We know that as delta x tends to 0 and delta t tends to 0 and delta y tends to 0, then delta y out of delta x will tend to dy dx. Delta y out of delta t will tend to dy dt. And delta t out of delta x will tend to dt dx, such that our equation becomes dy dx is equal to dy dt times dt dx. And so this is how we differentiate composite functions. So if you look at the examples we had initially, you'll see that we had y is equal to x plus 3 squared. Now if we let t be x plus 3, we could write this as y is t squared. Now remember we want dy dx, and from the chain rule we saw that dy dx is equal to dy dt times dt dx. So from this equation here we can get dy dt. You can say dy dt will be 2t. Then from this equation here we can get dt dx. You can say that dt dx will be 1. And therefore dy dx will be 2t times 1. But our t in terms of x is x plus 3. So it will be 2 times x plus 3, which is 2x plus 6, which was what we got initially. Now how about for this case? If we let our y to be equal to x squared plus 3x to the power 7, realize that we can let our t to be the function in the brackets, which is x squared plus 3x. And so we can rewrite this as y is t to the power 7. And so dy dt will be 7t to the power 6. And then the t dx will be 2x plus 3. We can write dy dx as 7t to the power 6 times 2x plus 3. What is t? T is x squared plus 3x. So 7 times x squared plus 3x to the power 6 times 2x plus 3. And you can see that in this, the highest power of x will be 13, which is what we expect when we expand, when we expand this. And so this is how we use the chain rule to differentiate. Now you realize that what we are basically doing is, differentiating as if x plus 3 were x, and then multiplying by the derivative of x plus 3. In other words, multiplying by the derivative of what's in the parentheses. And so that's what we shall be doing. So we have a scenario like this where I've been asked to differentiate this function with respect to x. We can write this function as 3x plus 2 raised to the power negative a half, because it's 1 out of the square root of 3x plus 2. And so the derivative with respect to x of 1 out of 3x, the square root of 3x plus 2, is going to be equal to negative a half times 3x plus 2. The power reduces by 1, so it's going to become negative 3 out of 2. But then times the derivative of what's inside the brackets, which is 3. And so this will be negative 3 out of 2 times 3x plus 2 raised to the power 3 out of 2. Now, of course, you could write that as negative 3 out of 2, the square root of 3x plus 2 cubed. You could write it like that. And so that would be the derivative of the function given. Okay, how about a function in this case? Now, in this case, realize that we would not only have to use the chain rule, but we'd also have to use the product rule. So you can see that the derivative with respect to x of this function is the same as the derivative of x plus 1 to the power 3 out of 2 out of x plus 2 to the power a half, because of the square root. Now, using the quotient rule tells us that the derivative of u out of v with respect to x is v du dx, and now v is the denominator, so that's going to be v times du dx, the derivative of the numerator. So I'll just write that as v dx of x plus 1 to the power 3 out of 2 minus u times dv dx. So the numerator times the derivative of the denominator, x plus 2 to the power half, divide by v squared, which is the denominator squared. So x plus 2 to the power half squared. So this gives us x plus 2 to the power half. Now the derivative of x plus 1 to the power 3 out of 2, we said is going to be 3 out of 2 times x plus 1 to the power a half, power reduces by 1, then times the derivative of what's inside the brackets. Now you can see the derivative of what's inside the brackets is just going to be 1. So there's no need for us to add anything there, which is what happened in this case. The derivative of what's inside the brackets was 1. So even by not knowing, we still end up with the correct derivative. So that's what happens when the derivative of the inner function is 1. Similarly, we'll have x plus 1 raised to the power 3 out of 2. And this is going to be multiplied by a half times x plus 2 to the power negative a half. All this is out of x plus 2. Now you can factorize. We can factor out a half. We can factor out x plus 2 to the power negative a half and x plus 1 to the power a half. So what we'll be left with on the inside, we'll have a 3 times x plus 2 on this side minus, I believe this will be minus x plus 1. And all this is out of x plus 2. And so in the numerator, what that leaves us with is x plus 1 to the power half. And the denominator we have 2 times x plus 2 to the power 3 out of 2. And then, of course, what's inside the brackets here, which is going to be 2x plus 2x plus 5. And so this is our final answer. Of course, you could end up writing it as half times the square root of x plus 1 out of x plus 2 cubed times 2x plus 5. You could write it like this. There's no harm. And so that's how we use the chain rule to differentiate.